Welcome back to 30 Days of Physics with Miss B, and we're moving right along into light waves. Is light a wave or particle? That is the question. It is the same question many scientists asked themselves throughout the 17th to the 20th centuries. Scientists such as Huygens, Young, and Foucault suggested that light is a wave, while Newton suggested that light is a particle. Huygens in 1690 suggested that light was a longitudinal wave which could travel through a vacuum. His reasoning? A material called ether filled all space, even if no matter was present, therefore explaining why a longitudinal wave was able to travel through a vacuum. Newton, on the other hand, proposed the particle or corpuscular theory in 1704, stating that light was shot out from a source as particles. He believed that the mass of the source diminished as it released those particles. Diffraction had not yet been observed, so Newton said that since light could not diffract, it must not be a wave. Young actually performed an experiment in 1802 by allowing light to pass through two slits. From this, he observed the production of bright and dark fringes of light on a screen. This behavior of light rays showed that light diffracts and interferes, much like how a wave does. In 1850, Foucault experimentally determined that light traveled faster in air than in water. This totally contradicted Newton's wave theory of light. Basically, the wave theory and the particle theory of light were conflicting. Even though observations were made that proved the light had properties of a wave, they were ignored because of Newton's reputation as a well-known mathematician and physicist. In the end, Max Planck in 1900 combined both the wave and particle theories by producing the quantum theory. The quantum theory explains the nature and behavior of matter and energy on the atomic and subatomic level. Then, in 1905, Einstein, the scientist responsible for change of energy is equal to the change in mass times the speed of light squared, showed that the phenomenon of photoelectric emission could not be explained by wave theory, only by the particle theory, while the particle theory could not explain phenomena such as diffraction and interference, which are both properties of waves. Today, we see that light is both a wave and a particle, since it exhibits properties of both, where each wave pulse is a packet or particle of energy known as a photon. Diffraction is the spreading of a wave as it passes an edge or goes through a gap. The wavelength of light waves is very small, and the smaller the wavelength relative to the gap, the lesser is the diffraction. Light diffracts if it passes through an extremely small gap. Interference is when two waves superpose upon each other to either form a larger amplitude, better known as constructive interference, if they are in phase, or form a lesser amplitude, better known as destructive interference, if they are out of phase. Constructive interference of light increases its intensity, while destructive interference decreases the intensity of light. Young's double-slit experiment showed the interference of light waves. The interference shows up as light fringes, constructive interference, and dark fringes, destructive interference, on a screen. In this picture, please note that there is diffraction happening through the gaps, and there is interference happening. Wherever a crest and a crest, or a trough and a trough meets, you will have constructive interference. So here you have a crest and a crest, a crest and a crest, a crest and a crest. And here you have troughs in between. The spaces in between represent troughs, right? However, wherever you have a crest and the space of a trough meeting, you would have dark bands being formed. Okay, so that is known as destructive interference. A ray of light is the direction in which light propagates, while a beam of light is a stream of light energy. Rays of light are depicted as arrows within text. Beams of light are depicted as many arrows going parallel to each other. Light travels in straight lines. Owing to this, when it comes into contact with opaque objects, the light is unable to pass through it or around it, so a shadow is formed. The darkest part of a shadow is referred to as an umbra. Partial shadows are referred to as the penumbra. Point sources of light produce umbras, while extended sources of light produce both umbras and penumbras. An eclipse, which is a natural phenomenon, allows us to experience umbras as total eclipses and penumbras as partial eclipses. When the Earth blocks the sun's light from the moon, a lunar eclipse results. When the moon blocks the sun's light from the Earth, a solar eclipse results. Alright guys, I'd like to thank you for watching 30 Days of Physics with Miss B. See you around for the 24th episode. Bye!